Good day everyone, we are Team 20, part of the first Climate Plus cohort. In this video, I am joined by my groupmates Sad and Rebecca, and our project is entitled Tracking the Causes and Impacts of Climate Change Using Satellites and AI. Before we start, we would just like to show our appreciation to our project manager Zach and leads Professor Kyle and Professor Jordan. Climate change has negatively impacted energy, food, infrastructure, transportation systems, human health, and water supplies as shown by the decline of Lake Powell in the US. With satellite data, we can regularly assess affected resources and infrastructures by training machine learning models to do tasks such as crop field delineation, solar PV detection, building segmentation, crop type mapping, etc. This ultimately paves way for policymakers to develop mitigation and adaptation strategies.
However, limitations still exist. Due to the diversity of the various tasks, we need to separately train accurate supervised learning models using large, labeled, and expensive-to-acquire data. Yet even with those expensive labeled data, these models trained still fail to generalize well due to large geographic and sensor differences.
We overcome this need for labeled data by training a self-supervised model on a large, unlabeled satellite imagery dataset. In this summer, we laid the groundwork for this larger project by creating a methodology to collect a brand new, global, curated 10 million satellite images dataset.
In order to ensure that our dataset captures mostly human settlements, we selected the 10,000 most populated cities of the world and sampled coordinates from multivariate distributions centered at each city. We're doing this because we want to track how the man-made facilities are affecting and being impacted by the climate change. We also weighted the cities based on the population so that more samples are generated from cities with denser population. In the map shown in the slide, each black dot represents the location of a set of coordinates generated, and as we zoom in, we can clearly see from the picture that the coordinates generally cluster around the cities. After 10 million sets of coordinates are generated, we then pull satellite images from those coordinates.
Using our dataset would allow for the training of a self-supervised model using primarily unlabeled data. This is different from the existing paradigm where for each task we need one large labeled dataset to train one specific model. We believe that self-supervision may unlock the potential of available unlabeled satellite imagery, and our work will allow us to explore the hypothesis that we can use one model that generalizes well across both geographies and tasks.